Okay. So we're going to be talking about transformations of functions, and we're going to start with just the idea behind this. So we're going to do what's called a problem string. Take notes on what I'm talking about with the math behind it as well as just the problems. What is 5 times 5?
25.
Is that the same thing as negative 5 times negative 5? What is 9 times 9? Don't call it the answers. Okay, who has it? What other numbers can I multiply the same thing by itself to get 81? Negative 9. So negative 9 times negative 9 is also 81. I know it seems very basic. Y'all have known how to multiply numbers by themselves for a few years. We're going to be looking for pieces of this when we're doing quadratic transformations. And so, what if I ask you some number times itself is 16? What is that number? Think quietly before, so that everybody can think. Who thinks they might have the answer? What number is it? Is that it? That's the only number I can put there? No? What number is it?
Negative 4.
So 4 or negative 4. Because 4 times 4 is 16. Negative 4 times negative 4 is also 16. What number times itself, then I subtract 9 from it, is 16? What number times itself, then I subtract 9 from, is 16? And when you get to the answer, be able to explain why you think it is, how you got there. Give me a thumbs up when you think you have it. So what number is it? Why is it 5? Okay, so you're thinking, so 5 times 5 is 25. Then you subtracted 9, and you got the 16. So how do you know you were looking for 25?
Because we moved the 9.
You move the 9 over?
Yeah.
So move the 9 to the side of the 16. And so what'd you do when you moved it over? Subtracted 9?
You added them.
We added 9 over here. And so that got you the goal of 25. So x equals 5. Is that it?
Or, yes, -5 plus.
Or negative 5?
Yes.
So they still both matched. They're still both positive and negative. What if I take some number and I square it, then add 7, and it equals 16? What is that number? Don't call it out. Think it through. Give me a thumbs up when you have it. Dylan, do you think you have it? No. Okay.
Oh.
Allison?
3.
3? How'd you get there?
Well, because 3 squared plus 7 equals 16, I just put 3.
Okay, so how'd you know you were looking for 3 squared? You just try different numbers?
Yes.
Okay, did anybody go another way? Besides plugging in numbers.
Fraction.
And so that got you your goal?
Yes.
So as we have our goal, we know we need something squared to equal 9. So is 3 the only answer? But you're right, would work. What you were doing would work. As long as we have whole numbers. What if I start throwing in integers, we need to find a, or find a value way of, not integers, when I start putting in real numbers, we need to find a way to mathematically solve it. What if I take a number and I subtract 1 from it, then square it, and it's equal to 9? What is that number? Take a number, subtract 1 from it, then square it. Thumbs up when you have it. Give me 2 thumbs up if you think you really can explain it. Elijah? How do you explain what you got?
You'll subtract the 1 from, or I just started by plugging in numbers.
You did it by plugging in numbers? Did anybody do another method besides plugging in
You have
numbers?
to take the square root of 9 first to get the x minus 1
So you take the square root of both sides. Well, basically you're taking the square root of both sides when you do that. And so you're getting a goal of 3.
and then you have to add the 1.
No, it's not 3. Is that the only answer?
No.
What would be the other one?
Negative.
Negative 2? How can I, what would I do to get that? How can I prove what I got there?
You could
Plug it in. Couldn't what's inside the parenthesis equal a negative 3? And now we can solve the next equation. And so that gives us our two answers. 4 and negative 2. So this time I'm going to take a number and add 2 to it, then square it, and equal 9. Take a number, add 2, then square, then that will equal 9. And so see if you can come up with a way besides just plugging in numbers. So we can do it consistently no matter how crazy the numbers might be. Give me a thumbs up if you think you can explain it.
Okay. First, you find the square root of each side,
Okay.
and then
What number was that?
the square root of the first section is x plus 2.
Mhm.
Then the square root of 9 is 3. Then you minus 2 by both sides to get you x equals 1. And then you could do x plus 2 equals negative 3. And then minus 2 on each side. That gives you x equals negative 5.
So I guess you your two answers. Is everybody able to hear? Okay. Last one. I take a number, I add 2, I square that number, then I add 1, and I get 26. Take a number, add 2, then square it, then add 1, and that number equals 26. Okay, so maybe we want to try something different to get there.
And then, so, one from here, it still comes out.
If you minus 1 from here,
I added some.
if you came up with a decimal, I would try again. It's not going to give you a result in a decimal.
Okay, so I just subtracted 1 on both sides to get 25. And then I took the square root of both sides. And then I just subtracted 2 to get what x was.
Is that the only x?
No, I got another one too.
How'd you get the other one?
So when I got to x plus 2 equals 5, I just made it a negative 5 and then solved it the same way and got negative 7.
Okay, so for each of these times, we keep taking the square root. So basically, the square root is what we're thinking, what squared is going to equal 25? So we've been taking the square root. That's the way to do it when either the square root's not easy known, so maybe it's a random weird one, or let's say I asked you to take the square root of 26. Can you find the square root of 26? So when it's not a number that we can know offhand, it may be a number that's a irrational number, and so that square root comes in handy. Why did we always do the plus and the minus? To get both sides. Because we don't know if it was a positive 5 inside that parenthesis or a negative 5. So it's 2 different times. So think back to last semester when I was tossing that tennis ball. And y'all clapped hands. Sometimes you clapped once. Sometimes y'all clapped twice. And sometimes you didn't clap at all. So sometimes we're not going to have a solution. And what it is an imaginary solution. And we'll learn about those throughout this unit. But just realize that you could end up with one solution, you can end up with 2 x's, or you could end up with no solutions. For all the ones we're doing right now, we're going to end up with 2, but just realize that is a possibility to have only 1. And so I want you to see if you can brainstorm and come up with a time when you might only have 1. When it's equal to what?
Oh,
Go ahead.
0.
0. Because is there a positive or negative 0? 0 is neither positive nor negative. And so that's one time where you would end up with only 1 solution. Does the solution always have to be 0 in that case? Or could there be other numbers? So does it have to equal 0? You know we need something squared to equal 0. So is there a time where there will be more than 1 solution on that? I mean, more than just 0 for the answer on that.
Yeah.
Yes? What would it have to be in the parenthesis? Give me a scenario that would work.
Put in anything like x plus 5 or whatever.
So then that would be a situation where x would have to be negative 5 in order to create that 0. But you wouldn't have a positive 5 to go with it or any other number to go with it.